Hey everyone, I'm John McCutcheon. You might remember me from a couple hours ago. But instead of games, I'm here to talk about Dart. I'm an engineer on the Dart VM team, and the goal of the team that I'm on is to really make the web faster. Our goal is to make applications run at least twice as fast as they can in JavaScript. But this talk is going to focus a lot on what Dart is and its philosophy and the feel of the language. But before I start, how many of you have heard of Dart? And how many of you have tried out Dart? Taken a look at it? All right. Well, I hope to change some minds here. So I guess you could capture a lot of Dart's philosophy with this phrase, batteries included, which in America means it comes with everything that you need to use it. So Dart has it's not just a language, but there's actually standard libraries. There's tools, an editor that understands the code base, can give you auto-completion, everything. There's a virtual machine, that's the team that I work on, and that's head by Lars Bach, who used to do V8. You might know V8. And then there's a compiler to JavaScript. So even if your browser doesn't have the Dart virtual machine, it doesn't matter, because you can compile Dart source code to JavaScript, and it runs just as fast as handwritten JavaScript. And you'll see the compelling reasons of why you might want to code in Dart versus pure JavaScript. So here's a little story here. So I want to build a web app, right? This is the state of the world today if you're a JavaScript developer. Well, you'll get Backbone and Backbone Marionette and jQuery and Modernizer, and it just goes on and on and on. It's kind of crazy, right? There's no standard stack. There's no default way that everyone who's writing JavaScript writes JavaScript. Every JavaScript project kind of handpicks a few of these libraries that they like and goes with it. But Dart has all of these things included, so there's a little bit of sanity here. Things are very consistent. So the Dart SDK is the base here, and then what we have is a package system where Dart library developers can upload their packages to a central repository, and then you as a Dart programmer can just say, well, I want to use the unit test library, and I want to use web UI, and I care about internationalization, and you'll just get those packages. And every other Dart program out there is going to be using these same packages. So there's a little bit of consistency. But then we want to scale web apps up. Right now, it's very difficult, even inside of Google. We've got dozens to hundreds of engineers working on millions of lines of code. There's all these different layers. There's GWT, there's Clojure, there's SOI. But the productivity is impacted by this because there's no edit refresh iteration cycle during development. You have to go through all of these different intermediate steps just to see the change that you made in the source code actually show up on the site. So this is kind of like a running theme here with Dart, is that we can do better than this. And there's a lot of competition in terms of languages to replace JavaScript, and in a way that confirms one of Dart's goals, which is that the JavaScript has certain flaws, and there's a lot of languages out there that are trying to kind of paper over these flaws and make it easier and more digestible. So there's Dart, there's Clojure, there's CoffeeScript, there's TypeScript, there's GWT. But when you compare all of these things, Dart has some really compelling things. In particular, the rightmost column here, performance. These other languages are always built around the idea of compiling directly to JavaScript. So the performance is kind of like, however fast you can run JavaScript, that's how fast your program-written CoffeeScript or TypeScript can run. They can't run any quicker. But in Dart, with the Dart VM, you could theoretically run twice as fast. So let's give a quick tour of what Dart source code looks like. So Dart is class-based, it's object-oriented, it's not prototype-based the way JavaScript is. The one running theme with Dart source code is that it's familiar. If you're familiar with a language like Java or C or C++ or C#, you're going to feel right at home with Dart. It's very similar. So let's make a class hug. And there's hug can have a strength to it. How strong am I hugging you? But you can be really terse. A lot of the time in your constructor for a class, you open it up and you just take the parameters that were passed to the constructor and assign them to member variables. In Dart, there's just shorthand. You see hug this dot strength. That just means it's shorthand for saying take this parameter and assign it to my member variable strength. You can have named constructors, so you can have a secondary constructor. So if you just want a shorthand for like a super strong bear hug, just do hug.bear and strength is set to 100. You can do operator overloading. This is something that's not possible in JavaScript today. This allows you to take two hugs and add them together. And in this class, that means adding their strength together. You can have named optional parameters. So you don't have to pass parameters always by the order that the function accepts them in. You can actually provide names and make them optional and give them default values. So, by default, if I want to pat back, it's just one hand. I'm not using both of my hands. And there's also, this is another example of how terse Dart can be. Here's toString. If it's just a one-line function, why have a curly brace and all of that extra syntax with it? You can just do a fat arrow syntax, and that fat arrow says return whatever's on the right of this as the result of calling this function. We also have string interpolation. So instead of having to use the add operator to combine strings together or to take a variable and convert it to a string, you can actually just use this $sign syntax here. So if you had a hug and you wanted to print it to the console, it would be, the embraceometer reads strength, whatever the value of strength is at that time. So one of the most important things to me as a developer about Dart is that the semantics are really clean. I come from a C++ background, so coming to JavaScript, I get confused. I don't understand what's going on. I compare two things that shouldn't be equal and they're equal, or the other way around. Dart, that's not going to happen because only true is true. And there's no undefined, that doesn't exist. It's just null. There's no type coercion. If I say, is A equal to B, they're not going to try and, the language is not going to try and make them equal. It's just going to evaluate the equals operator and return true or false. That's it. So what happens if you try and access some value on an instance that doesn't exist? Well, you actually get a proper no such method error. The class string doesn't respond to the missing getter. And we'll see more on no such method as we go on. But this is very logical, right? Like you asked for the missing property on the string, on a string. And instead of it just kind of magically giving you undefined or null, you're getting a proper error message, telling you who the receiver was, a little bit of a message, any arguments passed to the function. What about an index out of range? This is completely valid in JavaScript. You can just, ask for this, you'll get something back. In Dart, you actually get a range error. This array does not have a 99th element, so it can't possibly give it to you. So this stops you from kind of cruising through development, not realizing that you've made a lot of subtle bugs inside your code. So this is something that, for me, JavaScript is incredibly confusing, is variable scope. So we see here that we have many foos, right? We have a foo that's local to the bar function, and we have a foo that's in the global scope. But there's no hoisting, right? You can see that the foo inside the if not true branch doesn't override the foo that's in the global scope. So this kind of operates the way languages like C and Java and C# work, where the scoping is truly lexical. And this is like every time I program in JavaScript, I make this mistake where I have the this is not the this that I expect it to be, but in Dart it always is the this that you expect it to be. So there's a real scalable structure. If you want to use a library in Dart, you actually have to explicitly import it, and you have to name your libraries. So everything, again, there's a lot of structure here. So you can see on the right-hand side of this slide, I'm making a library. I'm calling it games. So if I wanted to upload it as a package, you could use my games library. And my games library needs the math library, and it needs the players library, and there's all these different classes in there. But let's dig deeper into what's new in the Dart language. So if we look at this, we see var button is equal to new button elements. We're making a button element. We're going to insert it into the DOM. And we want to set its ID to fancy and the text is click, and add the important CSS class, and set up a listener for a click. And then finally add it to the DOM at the end there. In Dart, we have this ... syntax. So you can say var button is equal to new button element ... ID equals fancy ... text, etc. Right? So this saves you a lot of typing, and it becomes clearer that you're kind of doing all of this as one unit of logic. And you can even go so far as just put that right inside the children.add. So you can do new button element ... So when this expression is evaluated, your button element is entirely initialized the way you want it to be, and then it's added to the DOM. So, what if you wanted to serialize a hug object? You wanted to put it into a data store somewhere, put it in a database or something like that, make it persistable. In a class-based language, you would think, okay, well, I'll make a persistable class and then have all the classes that I want to serialize into this persistable data store inherit from that. But that's not really what object-oriented inheritance is supposed to be. So Dart actually has this concept of a mix-in. So hug is still just inheriting from the base object, but you can actually mix in functionality. So it doesn't alter the class hierarchy, but it provides new functionality to your class. So if we have this abstract class persistable, which has save, load, and toJSON, we can say that class hug extends object with persistable. So hug gets the functionality of the persistable class, but it doesn't pollute the class hierarchy in a way that is not logically sound. And then here we say, let's instantiate a new hug and then call save on it, and it's going to go into some database somewhere. So libraries and JavaScript interoperability. So one thing you might be wondering about Dart is, okay, it's this new language, it's running on the web, but can I use all this JavaScript code that I already have written? And the answer is yes. It's actually relatively straightforward. There is a Dart library that allows you to proxy between JavaScript objects and Dart objects and pass them back and forth. So here's a little example. The Dart code up here reads like this. So you get the charts API out of your JavaScript library. You create a new JavaScript array, and then you create a new chart by proxying it through the JS library, and then you just call chart.draw. Now this is actual JavaScript code if you were to be writing JavaScript itself. You can see that it's almost identical aside from a few extra proxy steps needed on the Dart side. So the point here is that it's very straightforward to take all of the legacy code that you have written in JavaScript and carry it with you into the new Dart land. So async with callbacks. We all know how many callbacks we have, and they can be kind of scary. So if we have this cat service here, and we get cat data cute, and we get the image ID, and then we rotate the image by 30 degrees. I mean, we're 4 levels deep with all this nesting of different callbacks and so on. But then you've got to do all this error handling. Like, what if any one of these single steps has gone wrong? You have to you're just repeating a lot of code here. So Dart has the concept of futures, and you can do a cat service get cat, and that returns a future, and then you can just do dot then and do the next step, and dot then and do the next step, and then dot then and do the next step. And the catch error at the end kind of handles all of them. So if any one of these steps fails, the error case is going to be executed at the bottom of the chain here. So you can actually compose futures, which is quite nice. So if you want to get two different cats, but you want to do all the logic only once you have both cats, you can do this, you get two futures back, and then you call future.wait and pass in the list of both of them. And then when that future will complete when they're both completed. And if any one of them has an error, the catch error will fire at the end. So asynchronous with futures, it's a little bit better than a fiery hellscape that we saw before. So streams, this is another concept that is baked into the core libraries of Dart. So this isn't all of these things like futures and streams are not extra libraries that you go and you download and you put into your site. This is part of the language in the base SDK. So we're all starting from a much higher place than starting from the blank slate. So streams are a series of asynchronous events. A future is an isolated asynchronous event. A stream is a series of them. So you can think of streams like bytes from a file, messages from a WebSocket, button clicks, incoming connections. And basically all you have to do to consume things from a stream is just this single line of code at the bottom here, which is stream.listen. You're given whatever the asynchronous event is, and you do something with it. So let's take a look here. We have on element, there is a stream for key presses. Right, so query the DOM. This is another nice thing. Query is just baked in to the platform like this. So you have query for text area, and then on key press, where the keys are between 32 and 122, map the character code to a string first. Right, so this is just going to first returns the very first key press. That's it. Then print the first character pressed on the keyboard is equal to that character. So web programming with Dart kind of looks like this. So you have window.navigator, get user media, get the video element. You can see the dot syntax, the listen, catch error. XHR requests with Dart look like this. It's very straightforward. Again, you can see how easy it is to kind of compose all of the stock Dart SDK features together into some really tight-looking code. So you can we have event sorts mapping, which is kind of cool. Like, so if you have document, body, onclick, matches, thread. So listen and then print, super cool, right? So this will dynamically, if anything on the document that has the CSS class thread gets clicked on, this is going to fire. Even if the class gets even if the element gets the class later on after this code is executed or is removed, it's dynamic. It will just always respect whichever element has the .thread class. We also have automatic sanitization. So if you want to take some user input and put it into the inner HTML of an element, it's not possible to have, for them to insert a script tag and run it in there. Dart actually will make sure that anything that is potentially a security exploit is removed when you assign to inner HTML. So web components, we've been talking a lot about web components, and Dart fully supports them. So, this is the classic example of how great web components are. I mean, here's on the left some variant of Gmail, and then on the right something that logically makes sense, where you have a messages and message with subject. I mean, these new custom elements really allow you to make kind of logical and semantic sense of the tags in your page, rather than just div and table soup. There's encapsulation with custom elements, so you have structure and your behavior and styles can all be hidden inside of these custom elements. And they're reusable. You can just import the library and import the HTML file for the custom element, and there you go, you've got your own custom element. There's data bindings between the DOM nodes. So Polymer.Dart kind of fits in at the foundation and the core level. So size and speed. One of the goals of Dart, aside from speed, is that we can support really large-scale software development. Because the language is so structured, it's much easier to make sense of what's going on, and the editor actually allows you to hyperlink through your source code and get to different functions and pop around. It's quite nice. So by running faster, you actually save battery, because when you're executing your code, it takes fewer CPU cycles. So on mobile devices and laptops, tablets, etc., running faster actually will lead to longer battery life, which is awesome. We all want that. So like I said at the beginning, there's two ways to run Dart code, right? You can run Dart in the Dart virtual machine, or you can compile Dart to JavaScript. And the Dart to JS compiler does a really fantastic job of compiling Dart code down to JS. So if we look at this snippet of code here where we have var Bob is equal to new person Bob Smith, and then we query the DOM for something, and then we set the text of that DOM element to Bob's first name, Dart to JS compiles the code, and it looks like this. I mean, it's practically human readable. It's a lot of the time a direct one-to-one mapping between Dart code and JavaScript code. So you can also get minified code. So at the top here we have the by default what Dart to JS will generate, and then you can pass in a flag that says, okay, compile this, but also minify it, and it becomes illegible like all minified code. But this just again helps you save space when compiling Dart to JavaScript. So we also have something built into the compiler called tree shaking, and because Dart is so structured, we can actually reason about what pieces of code are used and which pieces of code are not used. So even if you import many, many libraries, but you only call a few functions, the Dart to JS compiler has this phase called tree shaking, which you just shake the tree and all the stuff falls off of it that you don't actually need, and you end up with this really minimal code right here, which is that main calls func2, which calls funcx. Func_y and func_1 are never invoked, so they're not included in the Dart to JS output. The Dart VM, this is the project that I work on. Because Dart is such a strict language, this actually allows the virtual machine to run faster than any JavaScript virtual machine can. We went over it a little bit earlier, like there's real arrays, there's real classes, there's direct calls. There's no walk up the prototype chain, find the first object that can respond to a method and then invoke it. The VM will actually globally track field types. So if you have class person and it has a field called name, if name is always a string, then we know it's a string, always. And the VM will track this, and you can actually, we saw, when this was enabled, we saw kind of across the board 20% speed up just from this one optimization. So one thing that I actually personally worked on was bringing SIMD to the Dart VM and to the web for the first time. So this is the CPU die of a dual-core ARM processor. So you can see that the kind of the bluish core area there, that's like where your integer arithmetic, your just general CPU computation occurs. And then you can see VFP, that's where your floating point, your double precision numbers are being executed. And then we have this red area here, neon, and this is where the SIMD portion of the CPU is devoted. So if you look at how much silicon is devoted on every CPU in your laptops and your tablets, there's a ton of silicon devoted to the SIMD processing, which up until the Dart VM, added support for SIMD, it was impossible to tap into. So you're looking at maybe 20% of the surface area of your CPU is just sitting there idle. You cannot access it as a programmer, and there's huge performance gains to be had from being able to tap into this. Let me just show you a demo here to give you an idea of what's possible, especially when it comes to 3D games, with SIMD is enabled. So what you're seeing here is a bunch of monsters from Doom just kind of standing around, animating, doing whatever. And this application is attempting to keep as many monsters on the screen as possible and still run at 60 frames per second. So there's just this adaptive algorithm in there. That's why you see them kind of popping in and popping out. We're trying to keep it about 60. So right now SIMD is off, but if I turn on SIMD, this is a massive speed up. I mean, we were at like about 13, and now we're in the high 60s, low 70s. This is because the Dart VM actually lets you tap into that huge amount of silicon on your CPU that's specially designed to accelerate things like image processing and 3D graphics. So I've been talking about performance a lot, and we have some publicly tracked benchmarks. So internally, during my games talk, I talked about how we have this infrastructure where we track the performance across all of these benchmarks on every single commit. And so these are current numbers right now. The green numbers are, okay, so first of all, the y-axis, higher is better. You're running faster the higher the bar is. Green is Dart to JS. So we take the Dart code, we run it through the Dart to JS compiler, and then we execute it inside Chrome. Yellow is handwritten JavaScript. So some human went out and wrote the same algorithm in JavaScript, and it's running Chrome. The blue bar here represents the performance when running under the Dart VM. So you can see for Delta Blue, you can see that Dart to JS actually greatly outperforms handwritten JavaScript. And the Dart VM just destroys all of them. I mean, it's ridiculously fast. Richards, Dart to JS. So for Richards and Tracer, Dart to JS does not do as well as handwritten JavaScript, but it does a respectable job. And then again, you can see how much faster the Dart VM is compared to JavaScript. And with the Tracer, which is a ray tracing benchmark, we're 2.3 times faster than handwritten JavaScript. So we also have an N-body, which is a solar system simulator. This is another benchmark that we track. And this is performance numbers in Chrome Mobile. So on an ARM device, your cell phone running Chrome with the Dart VM baked into it. So we have handwritten JavaScript, yellow here, and then the light blue is just the Dart VM, and we're 1.48 times faster. You can also port the N-body benchmark to take advantage of the SIMD support in Dart, and when you do that, Dart is 2.42 times faster than handwritten JavaScript. So Dart is an extremely structured, kind of sane language that, when run under the Dart VM, can run at least twice as fast as JavaScript can. But we really haven't scratched the surface. There's so much more to Dart that we just don't have time to go into in this presentation. Dart has great support for reflection, so you can do things like, I want to iterate over all the libraries that were imported, or find a class that responds to this method and then call it. There's server side. So you all, I'm sure, are familiar with Node.js, which runs V8. So Dart from the get-go has supported the model of running Dart code on both the server and the client. This has a great really makes code reuse really straightforward. You have a bunch of libraries which describe the kind of the structures that your application deals with, and you can share those on the server side and on the client side. The Pub Package Manager, which I mentioned earlier, which is just like an integral part of the platform. We have the editor, there's built-in support for unit testing, isolates for concurrency. So isolates are kind of like web workers, where you can farm off work and onto a separate thread and pass messages back and forth. So I really want to encourage you all to go out and try Dart. It's a really exciting language. I have a hard time going back to JavaScript after I've gotten used to writing in Dart. And we have a Dartisans community on G+, and you can send pull requests on GitHub. Dart is entirely open source. The VM, the Dart2JS compiler, all of the libraries, everything with Dart is open source. And we actually have active external contributors who are not Google employees, and I would encourage anyone here who's interested in participating to join these communities, get on the mailing list, start looking at the code, and feel free to ask questions on Stack Overflow. We have a lot of people that participate there. So Dart is a stable language, has stable core libraries, compiles to JavaScript. It's relatively evolved compared to where the web is today. And we're really committed to Dart, and we really want it to be a huge success. And thanks. I can take questions.
한국말로 질문하시면 제가 가능한 한 통역을 해보겠습니다. 질문 있으시면 질문하시고.
질문이 두 가지가 있는데요. 일단 첫 번째는 잡비용은 그러면 언제 크로미움하고 머지가 되는지 그거 두 번째 질문은 다른 브라우저 메이커들은 다트를 구현하는 데 별로 관심이 없는 것 같거든요. 제가 생각하기에는. 그래서 뭐 어떤 다른 브라우저들의 그런 뭐 구현 같은 걸 할 수 있는 그런 계획 같은 것들이 있는지.
So here's two questions. One is when will the Dart VM will be merged to Chromium or Chrome, and the other one is what's the opinion about Dart from other browsers vendors, and how are you going to collaborate with them or encourage them to
Sure. Yeah. We do not have a timeline for when the Dart VM will be included in Chrome. But if you download the Dart editor, it comes with a custom version of Chrome with the Dart VM baked into it. That's what I was running the Monsters demo running on. So you can, during your development, you can iterate very quickly inside what we're calling Dartium. And in terms of collaboration with other browser vendors, we are an entirely open source project, and we openly if another browser vendor wanted to work with us and incorporate the VM into their browser, we would love it. There would be absolutely no issue with that. But again, I just want to stress that Dart compiles down to very clean, very performant JavaScript code. So in some sense, it's irrelevant if other browser vendors do not include the virtual machine, because Dart code compiled to JavaScript executes very quickly. In which case, it's going to run everywhere. When you deploy a Dart application, you're not just deploying the Dart source code, you're also deploying the Dart2JS source code as well. And if your browser happens to support the Dart VM, you'll get something that runs significantly faster. If it doesn't, you'll get something that runs as fast as JavaScript. Other questions? Huh?
Dart is providing compiled source code currently. In case my source code needed to be protected from accessing of users, do Google have any official plan for supporting encryption or authenticating?
Not that I'm aware of. I mean, it's the web. Source code's out there.
But it run on VM, right?
Sorry?
Our source code is running on the VM, right? So what if Google support the obfuscate?
Yeah, I don't know. I mean, in some sense, that's kind of on a tangent and not directly related to Dart. I mean, maybe you want to encrypt your JavaScript source code and have all JavaScript engines know how to decrypt it, but I don't know. It's certainly not something we're working on right now.
It is official?
Hmm?
It is official opinion?
It's my opinion.
All right.
Other questions? All right. Thanks, everyone.